All right, so yesterday we reviewed all of the rules for radicals. Today what I want to do is briefly review what's important for absolute value and reciprocal concepts in this unit. So when we talk about absolute value, we're dealing with primarily, everybody, absolute value functions and absolute value equations. The first couple of lessons where we learned what absolute value was and you had to locate absolute value, you had to locate points on a number line to determine absolute value and all of that. That's unimportant. What this whole thing boils down to, whether you're talking about functions or equations, is that the absolute value of a quantity is equal to one of two things. It's either equal to the quantity or the absolute value of the quantity is equal to -1 multiplied by the quantity. That's it. That's what it boils down to. And that's what you do when you write an absolute value function in piecewise fashion. And that's what you do when you solve an absolute value equation. There's a catch, though. The catch, and I think everybody knows this, the absolute value of a quantity is simply equal to the quantity if the quantity itself was greater than or equal to 0, because then the absolute value signs are not needed. However, the absolute value of a quantity is -1 times that quantity if that quantity is less than 0. Because if that thing, Q, I'm calling it Q today, if that thing is negative, then you have to multiply it by -1 to make it positive. But here's the catch. When you put this into practice, when you put all of this into practice, these inequality statements have to be written in terms of x. So for example, and I'll pick an equation first and then we'll do a function in a bit. For example, if I said solve, and I'll use a very basic example, and I'm saying it's very basic for this simple reason. It's not even going to be quadratic. So when I ask you to solve this equation, I mean, it's pretty clear that we tear it apart into 4 minus 5x equals x plus 3. And -1 times 4 minus 5x equals x plus 3. Correct? That's what I just said here. But see, here's the catch. What I said here in the most general sense says equation 1 is true. I always use 1 for the equation that starts off with the inequality greater than or equal to 0. We said that the inequality is Q is greater than or equal to 0. But if you write this on an exam, that's not what we want. You have to write the subdomain there in terms of x, which means you have to rearrange this for x and get x is greater than or equal to, or x is less than or equal to. So you have to solve this inequality. This inequality doesn't go there. This inequality is used to find out what goes there. So because the x's are negative, I would solve it by moving the 5x over and dividing both sides by 5 and getting not equals, my mistake, and getting 4/5 is greater than or equal to x, but then you have to read it the other way. You have to say that means that x is less than or equal to 4/5. Do we need to repeat the process and put a less than here for the next one? No, we would just say that the opposite must be true. and the equals to is included. The equals to is always included with equation 1. And I would say to you that solving either of these equations is child's play. But I'm going to do it anyway just to get our brains moving. With equation 1, 4 minus 5x equals x plus 3. So 6x equals 1, x equals 1/6. And then what we have to do is look at equation 1. Are you guys with me on that? 1/6? I'm not all alone on this, am I? Okay. You have to look at this domain restriction that x has to be less than or equal to 4/5. So you want to take your calculator and find out. I mean, you should probably know 1/6 is less than 4/5, but if you don't, take 4 divided by 5 and say, oh, this is 0.8. Take 1 divided by 6, which is, I think, 0.166666, okay? And 0.1666, etc., is less than 0.5, which means that this 1/6 is, in fact, a solution. When you solve equation 2, you expand this out, you get negative 4 plus 5x equals x plus 3. Yeah, 4x equals 7. So x equals 7/4. Oh, okay, is 7/4 greater than 0.8? Yep. So this is a solution as well. So that's the whole principle behind these absolute values. That's what you're doing. If it were a function, I can give you one more example. If it were a function and I said write the following function, in piecewise fashion, what that means is you're going to write it as two different functions that put together give us this function. Well, one of the functions will be 3x plus 2 plus 1. The other function will be negative of 3x plus 2 plus 1. So the difference here is this is not an equation. You're not rearranging this for anything. You're just saying that that's what y is equal to. F of x equals 3x plus 3. F of x equals negative 3x minus 1. And then you have to put your domain in there. And you do that by saying that for equation 1, 3x plus 2 is greater than or equal to 0. And I'm getting 3 is greater than or equal to negative 2/3. I think you'll want to double check my work, of course. I think that's right. And then down here, of course, you're going to get x is less than negative 2/3. And you're done. This is not a case of you now solving anything. That's what we are asked to do. The difficulty with the absolute value equations and the absolute value functions is when the thing in the absolute value is quadratic. Because then you have to decide where is that quadratic, positive or negative. And you can't do it algebraically. You have to look at the graph. So for example, if I said the absolute value of x squared minus x minus 6 equals 12. Yeah, sure. Equals 12. And you want to break that up into two equations. One of your equations will be x squared minus x minus 6 equals 12. One of your equations will be negative of x squared minus x minus 6 equals 12. And just before I move on, I don't care where you're at in this course, you have to be able to solve two quadratic equations. That's a piece of cake. Right? You're going to zero each equation. Equation 2, I think you would be wise to multiply that -1 through first, but then you're going to zero it, and if you can't factor it, then use the quadratic formula. We can't shy away from the quadratic formula at this point. You're doing something in Math 30, you're going to need the quadratic formula from time to time. But the difficulty now becomes, what are the domains? And we will learn more about this inequality in the final unit of Math 20. But you should still know how to solve this inequality here. And the first thing you want to do is look at where it's equal to 0. And I believe this factors into x minus 3, x plus 2. What that means is it's equal to 0 at 3 and -2. So at -2, it's 0. At 3, it's 0. And you don't, when we first did this, we put numbers into the calculator. You don't need to do that. If this thing were graphed as a parabola, just this, it opens up, doesn't it? Because it's positive x squared. That means if it's 0 where my shoulders are, and it opens up, then it has to be positive to the right, it has to be positive to the left of my left shoulder from your perspective, and it has to be positive to the right of my right shoulder, and it has to be negative in between my two shoulders. So, I mean, what I'm saying is you know that the parabola must look like that. So it's positive over here, it's negative over here, it's positive over there. So what's your domain for the first equation? X is less than or equal to -2. X is greater than or equal to 3. And for equation 2, it's -2 is less than x, which is less than 3. I'm not going to finish this because, quite frankly, I think I've chosen an example here that would require the quadratic formula for each of these. Maybe not for the second one. I think the second one would be factorable. But you would solve each of these equations, and when you get the solutions for equation 1, if you get a number that's less than or equal to -2 or greater than or equal to 3, it's valid. If it isn't, it's not. You'd solve equation 2. Any number that you get for equation 2 solutions, which are between -2 and 3, are valid. If it's not between -2 and 3, then it's not valid. When I say it's not valid, it's not a solution. And I mean, the only other thing is reciprocals, right? Reciprocal functions. So, you know, we start off with radicals. We did radical equations and all that radical arithmetic. When you looked at absolute value, we did absolute equations, absolute value equations, and absolute value functions. Here, all we do are the functions. So just in a nutshell, I won't even write anything down right now. You need to know where invariant points are. You need to know where vertical asymptotes occur. You need to know the general shape of these things. Classic exam questions with regards to this would be, if, here's a real simple question. F of x equals x squared minus 2x minus 8 if g of x equals 1 over f of x, where are the vertical asymptotes of that function? I'm not going to ask you to sketch these things. Man, they're a pain, aren't they? You got to draw those curves through those invariant points and all that. Where are the vertical asymptotes? Wherever this original function is equal to 0, because you can't take the reciprocal of 0. So all you would be doing is solving this equation. And I'll leave it up to you to do that. That's a piece of cake. If I said, for the same question, what are the x coordinates of the invariant points? All that is important is you know that the y coordinates of invariant points are 1 or -1. So what it boils down to, is solving this equation and solving this equation. That's it. I mean, I'm not saying solving those equations is simple. I think probably both of them would end up using the quadratic formula. But that's how you would do it. And I admit I've picked on a quadratic one here. If it was linear, it would be even easier for both questions A and B. I would say these are the two big things, and I won't write this down. You can just listen to my words. You understanding that vertical asymptotes occur on a reciprocal function wherever an x-intercept occurs on the original. In other words, wherever the original is equal to 0. And the second thing is you understand that if y is 1 or y is -1, it's invariant. And that's it. That's what you need to know for reciprocal. And I literally, when I say there's two things you need to know, there might be 2 or maybe 3 questions, but probably 2, maybe 3 questions dealing with that. If there are, what are there usually? Around 20 questions in part A, and then a written response. Out of those 20 questions, 2 or 3 would be reciprocal. Absolute value, there's more meat to that. Maybe 4, 5 absolute value things, whether it's piecewise or absolute value equations. Maybe 3, 4. The rest is all about radicals. And while we're talking about the exam, we're into the algebraic phase of math now. Any written response is going to be about algebra. Solving equations is algebraic. So solving an absolute value equation is a good written response. I'm not telling you that's what it's going to be. I'm telling you that you need to know how to do that for the exam, and I think it's important. Radical equations, another one. And those are 2 really good equations to ask students to solve, because in an absolute value equation, you can get solutions that are extraneous, and for a radical equation, you can get solutions that are extraneous. And for both of those, you can get quadratic equations. So if I give you solve a radical equation, I give you this. That's a really good question. I'm just about done here. I want to give you an opportunity to continue working on the review. But that's a really good question to showcase your skills with algebra. Because, well, I would probably do this, by the way. I mean, I would probably make you work for it a little bit. Like you're going to have to move that 3 over before you square both sides. But when you do, you're going to end up with the square root of 4 minus 2x equals x plus 3. You're going to square both sides to get 4 minus 2x equals, and I I swear if I see this on an exam, I'm just going to, my top of my head will just pop off. Don't do that, right? You know that x plus 3 squared, quantity squared means x plus 3 times x plus 3. That's what it is. So x squared plus 8x plus 5 equals 0. I think I'm going to double check that because my work with numbers a little bit earlier was not that great, but I think that's right. Yeah.
6x? Or, oh, okay.
But I have the 2x from the other side, yeah.
Okay, yeah.
That's okay, yeah. I have the 2x from the other side, and that's where I'm getting the 8x from.
Okay.
Now, that's not factorable, but it does have solutions because b squared minus 4ac, and as we've been talking, I've just done it in my head, b squared minus 4ac, I believe, is, I better be careful here. You work it out for me. B squared minus 4ac, 64. I think it's 44. So, as I said, you're going to kind of showcase your skills here. Use the quadratic formula. I'm not showing all my work. You, of course, would. You get that. With any written response, I would always ask for exact values, so you should be able to, you ought to be able to simplify root 44. Into 2 root 11, because 44 is 4 times 11. I was doing some trig earlier, obviously. I've got pi on the brain. What are your two solutions? Negative 4 plus or minus root 11. But, and this is maybe good that I've thrown this up here. See, with absolute value functions, you look at the subdomain. Could we go up here and say 4 minus 2x must be greater than or equal to 0, otherwise you can't take the square root? Yes, but that's not what you would check your answers against. You would get x is less than or equal to 2. I don't know if you remember, but just because we get an answer that's less than or equal to 2 doesn't mean it's valid. With square root equations, with radical equations, you need to take these numbers and put them back up here. So you would actually have to do this. It was negative 2 plus or minus root 11? Negative 4, thank you, Ryan. So you would have to go negative 4 plus root 11, and then see if the square root of 4 minus 2 times that number minus 3 will give you that number. I'm going to put in for x on the left-hand side this number. So I'm going to have the square root of 4 minus 2 times that number. And I'm going to close the brackets on the square root, and I'm going to subtract 3. Got too many brackets? Yeah. Too many brackets. I get the number. It's valid. What was the other one? It was negative 4. Did I just do plus root 11? I did. So negative 4 minus root 11. So this is the other one. Okay. Well, I'm going to take the square root of 4 minus 2 times that, close the brackets on the square root, subtract 3. I don't get it. So that one's extraneous. You would say it's only negative 4 plus root 11. You know, and it could very well be something where when you square both sides, you might have fractions that you got to get rid of. There's all kinds of scenarios you can come up with. Anyway, I did say that I would go over a review of absolute value functions and equations and reciprocal functions, and I have done so, so you have lots of stuff you can be working on. As we've been talking, I'm printing off the extra practice handout if you want that. But for now, I think if you have your textbook and that handout in front of you, that's probably sufficient for now. I'm going to zip down to the photocopy room and see if it's ready, and I'll be back in just a few minutes. The thing about number 9 that makes it a little confusing is all of those extra brackets, and I'm not quite sure why they're there, but I guess it's trying to communicate to you that you're adding these binomials together. You're adding 5 plus root 50, and you're subtracting 8 plus root 4, and you're adding 6 plus root 18. First thing I'm going to do here, Taya, is I'm going to peel off all of those brackets. Remembering, of course, that when you subtract something in brackets, you have to subtract everything. So that's why it's minus 8 and minus root 4. And then all of these, like the root 50, can be simplified. Hopefully we've got enough practice with this that it's pretty apparent. It's root 25 root 2, and root 25 is 4. So it's 4 root 2. So we have 5 plus, 5 root 2. You wonder where that 4 came from, eh? Plus 5 root 2 minus 8, and then we have minus 2 because root 4 is 2, plus 6, and root 18 is 3 root 2, okay? And then we're pretty much home free because all of these things are what we would call coefficients. They're just numbers. We can add them together, so 5 plus 6 is 11. 11 minus 10 is 1. And I get 5 root 2 minus 3 root 2, which is 2 root 2. We take a look at this one. Each of those radicals on the left can be simplified. So root 18 is 3 root 2. Root 98 is 7 root 2. And if you didn't know that that's where it was going, you're told that this simplifies to 34 root 2. So it would make sense that these other ones have to be root 2's as well. So root 49 root 2 gives us 7 root 2. And then here we have k, and root 32 is root 16 root 2, or 4 root 2. And what this means, Taya, is that I'm going to take a risk with my highlighter. Yeah, I'm screwed. What it means is that all of these coefficients on the left have to add up to give 7. So 15, that 5 times the 3 is 15, plus this coefficient of 7, plus this coefficient of 4k has to be equal to 34. So what do we have? 22 plus 4k equals 34. So 34 minus 22 would give you 12. And then if you divide that by 4 to get k, you'd get k equals 3. So again, the idea, I think I've got it back now, is that these coefficients have to add up to give that coefficient. Hopefully that next one you can do now. Okay. You're welcome. It's really along the same lines as the one that that we were just doing, to add this number 10. And that, I think, is the next one, right?
Yep.
Okay. Do you see how it's similar to the numerical response one we just did? Okay. So Claire, if we look at this, if I'm telling you that these three radicals on the left add to give 70 root 5, it makes sense that they all must be root 5s. So that's maybe helpful in deciding what we're going to do with the root 20, although I would say knowing you, you know root 20 is 2 root 5. Okay. So we have 2 root 5 plus, what is root 80? Well, I think 16 goes into 80 5 times. So root 80 is 4 root 5. And we're multiplying it by 3. Did you forget the 3?
Yeah, that's where I went wrong.
So I just want to double check here. If you look at it now, this is a root 5. Do you see that the 2 plus this 12 plus this a has to equal 70? So 2 plus 12 is 14. Taken away from 70 is 56, so the answer is B.
Okay.
Number 19, did you say?
Yeah.
Okay. Well, everybody, you better make sure you know how to rationalize a binomial denominator. When we reviewed radicals and exponents yesterday, we didn't really go into too much detail about rationalizing, but I just said you need to know how to rationalize. So let's take a look at this one. So what do we want to do? We want to rationalize this. So I'm going to write -8. I better do this someplace else, or just give myself a little bit more room. I've got -8 root 7 plus 5 root 3 over root 7 minus root 3. The rule here, Claire, is that we're going to multiply the numerator and denominator whenever you have a binomial that contains radicals. To rationalize, you're going to multiply the numerator and denominator by the conjugate of that binomial denominator. When you multiply out the bottom, there is no need to FOIL it. I mean, you can, you know what I mean by FOIL, right? But because they're conjugates, if you look at your outer product is root 21, and when you look at your inner product, it's negative root 21, so they cancel. So all we're left with is root 7 times root 7, which is 7, minus root 3 times root 3, which is 3. We're left with 4 in the denominator, which, you know, we still have work to do, but it leads you to the conclusion that it's probably not choice D, right? In the numerator, we have to FOIL that mess out and see what we get. So if there's a time that calls for being patient and slow and careful and methodical, it's now, right? There's a lot of numbers floating around here. So negative 8 root 7 times root 7 is negative 8 times 7. Because root 7 times root 7 is simply 7. So what we're doing here, even though I didn't write this, is we're taking negative 8 root 7 times 1 root 7. We're multiplying the negative 8 by the 1 to get negative 8, and the root 7 by the root 7. My outer is going to be negative 8 root 21. My inner is going to be 5 root 21. And my last is going to be 5 times 3. So what do we get on top? I have negative 56, which is the 8 by the 7, and it's negative, plus 15, which is negative 41. Now we're down to A or B, and it looks like negative 3 root 21 on the top as well. So it's A. Does that make sense? Okay. I mean, this one is something that if you've had any difficulty with rationalizing those before, then go to that section in your textbook and try a few. It'll be on there on Monday for sure. Okay, of course.